I'm feeling much better after taking a break. I lost my side stitch and I'm ready to ride. In the prior video, I covered a smattering of metaphysical balls bouncing around fundamental physics that explain reality and our relationship to it. Everyone likes to think they've got the best beat on things, even myself. Especially when there is no consensus and everyone thinks they are an expert. First, we reviewed some metaphysical narratives that minimize, ignore, or actively deny reality. Why keep a raggedy old fiction that serves no real purpose except to comfort us? Second, we looked at the middle ground of accounts that construct a new form of abstract reality, a hybrid reality, if you will, unlike everyday first-hand experience, but still real enough. Shouldn't we replace an antiquated, broken-down something with a new and improved version? And third, we acknowledge some minority spiels that keep reality mostly unaltered, albeit micro, or as I propose, yocto in scale. If something can be fixed and still works, why junk it? Questions, questions, and more questions. In this video, we will look at how questions can drive history over millennia, and how we go about answering those questions, how we problem solve, how we navigate an issue. Primarily, we will compare how genetics and fundamental physics have used various inference engines to surmount the most difficult and persistent question. And that question at its most basic is, what is happening? At its simplest, the assumption and answer behind such a basic question is the second principle of object reality, what we used to call little r reality. It is the second principle of sophysism. An event happens. Boom. On its face, the answer may seem a bit cheeky. It is like how my kids used to answer the question, what would you like to eat? With a response, food. And no, a banana split with all the toppings does not cover the three basic food groups. Despite its formal correctness, the response does not step out certain sophistic assumptions, namely what an event smells like and what we expect to find when we go searching. Like in the first video, I will relate a personal story to provide a simple example of how we go searching abductively. In contrast to the very first video essay, which illustrated how we found a missing object from present curious events, the next example will show how we infer a past event from a present object, or more precisely, a present state of an object. You can probably surmise the overall approach being taken. It is like an old-fashioned shell game, except two shells have something underneath, and we have to find what is missing under the third shell. In this case, we will be finding the missing event. What is one more personal, life-changing event to dig into? Silly, really, in hindsight, but still impactful to my adolescent self. Let's get the boring watching paint dry on the wall stuff out of the way first, before looking at how abduction worked in my personal case, and historically for genetics and hopefully for physics. We will look at why each metaphysical approach in fundamental physics is taking the road they are taking. To conquer the enemy, we must understand ourselves as well as the enemy. As Pogo put it, we have met the enemy and he is us. As mentioned in the previous video, we have three tools in our tool chest we can use to find an answer to the question, what is happening? We may use one or more of the three inference methods, deduction, induction, and abduction. By way of pre-comment, the different color schemes for each method do not reflect any favoritism. They just seem to fit the characteristics of each tool. Specifically, deduction is black or white, a true conclusion or false conclusion. Induction is shades of gray, ranging from more probable correlations to less probable correlations. And abduction is multi-hued, the best explanation or the worst explanation. To review, here is a quick breakdown of each inference type and their corresponding elements. And like most of my explanations, these are oversimplifications of complex topics. It is a starting point for the parade. A journey of 1,000 miles begins with a single blind leap. Not that I have the complete confidence in my Google Maps. On to the first inference engine. At any point we may try to deduce our answer. The typical example of a deduction is a simple syllogism. If all never married men are bachelors, and the man Max has never married, we can conclude therefore that Max is a bachelor. There are also trivial examples in mathematics. If A is equal to B and B is equal to C, then we can conclude that A is equal to C. Of course, we don't have to look far to find examples where logic, mathematics, or their union have become useful and powerful. For instance, we use logic unconsciously to establish causality. It is hardwired into our brain and can be evidenced when we play tricks on our infants. Not that I ever have. Cross my heart. Hide beyond the sight of a 10-month-old child lying in a crib. Turn on her bedroom light each time she raises her arm, and turn it off when she lowers it. Soon she will be raising her arm, giggling and playing with turning the light on and off. Psychologically, she will think she is Captain Marvel. Subconsciously, she jumps from noticing the two events being associated to being strongly causally connected. Logically, it can be reduced to simple operations, such as conjunction and negation. I will push off the analysis of the steps to the videos on causality, but the end result is the conclusion that the light turns on if and only if she raises her arm. As for mathematics, Noether's theorem, which creates a mathematical correspondence between symmetry and conservation laws, is at the heart of much of modern physics. Then there's Boolean algebra, which equates 0, 1, addition and multiplication with true-false disjunction and conjunction to create the foundation of digital computer processing. To summarize the features of deduction in a sort of high-level and probably not rigorous way, the inputs are constants, assumptions, and first principles. The primary tools are logic and mathematics. The result is conditional truth. On to the second inference engine, induction. In order to resolve an issue, we may try to induce a conclusion. In its simplest form, induction is like deduction, except our assumptions are a little murkier and not 100% certain. Using the previous Max as a bachelor example, we might not know Max all that well. Max's past relationship history may be unclear, even if he is currently single. Max might have been married in the past, a divorcee, which would invalidate his bachelor status. Also, Max might be a nickname for Maxine, and Max might be a woman. Or even Max might be an infant, and it would be silly to call him a bachelor. If we really wanted to geek out, we could do a population study of a large group of Maxes to determine the relationships, if any, between the things called Max and bachelorhood. Not to be asleep at the wheel, gendered fluidity and non-binariness could be also taken into account. In the end, the result could be a correlation between things named Max and bachelorhood, all presented in shiny and impressive graphs. My daughter, who plans to be a clinical therapist, could give a much better rundown of induction. She did a study for her senior thesis, correlating emotional resilience and socialization during the COVID-19 pandemic. To continue filling out the inference engine table, the input tools for induction are observation, propositions, and population data. The tools are probability and statistics, and the result is the correlation between variables, or not. The third inference engine is abduction, in which we come up with the best explanation for what happened. Abduction is a workhorse of science, even if some in the physics community wish to keep it in the pasture. We went through a primate abduction example in the last video. I talked about how astronomers are trying to figure out how hot Jupiters, which have orbital periods under 10 days, happen. So far, our imagination has managed to come up with several potential explanations, ranging from hot Jupiters that coalesce close to the star, and those that form far away and migrate inward. The jury is still out on this particular issue, but it highlights an important feature of abduction. Key to creating and deciding among explanatory candidates is the discipline of sophysism, which I coined in the last video. Since I can't help myself, I am going to muddy the waters more and call it Sophism Plus. Kind of like Disney Plus. In a nutshell, Sophism Plus is experiential wisdom. If you can remember from the last video, simple sophism refers to the first principles and corollaries of object reality, such as an object exists. Sophism Plus will refer to sophistic systems that have been around the block a time or two. It is the understanding of how reality works, and using that understanding to interpret reality and build a model of a reality in our head. It is what a jury is called on to use when making a judgment about whether the defendant committed to the crime, which is step one in deciding guilt. In a more homespun version, sophism provides a framework for our house, and experience fills in the sheetrock. It will be a main thesis of this and the next video that we take Sophism Plus for granted, even though it is central to science and everyday life. At its core is a creative process on par with artistic pursuits such as filmmaking or authoring a novel. It is highly personal in its inception and mental gymnastics. However, to be useful and used, it must be shared and a consensus reached as to its efficacy. Ultimately, the final test is the question: given the evidence, what would a reasonable, unbiased person acting in good faith conclude? Of all three inference engines, abduction is the most subjective, and it is the easiest to gaslight. Of course, each creative endeavor has radically different ends. For example, art seeks emotional resonance, while science reaches for what we like to think is objective truth, free of emotion. After this brief outline, we will look at a personal, albeit simple, example of the use of abduction in everyday life to break down this process, which is not as rigid as the scientific method would suggest. To finalize the inference engine table, the input for abduction are facts, hypothesis, and evidence. The tools are sophysism plus and experimentation, and the result is theory. Just to be clear up front, it is not my intent to be a PC cop. I don't mean to imply that certain inference methods can only be used in certain disciplines or situations, that the inference engines cannot be combined or stacked on top of one another, or that terms like theory and law must be rigidly defined and can only be applied in specific cases. Even with the structure each inference engine imposes on its subject, their interaction introduces sweet complexity. For example, in trying to decide what caused the orbital irregularities of Uranus in the 19th century, several hypotheses were floated. One was that the Newton's law of gravitation did not work at the edge of the solar system. That is not so far-fetched, given that discrepancies in Mercury's orbit led to Einstein's general relativity, the replacement to Newton's gravity. Another one, the correct one, was that there was another planet, which we now call Neptune, beyond Uranus. To get nitpicky, an exception to Newton's law of gravitation would not be an explanation, even though it takes on the form of a hypothesis. To be accurate, Newton's law of gravity is an inductive correlation between the combined masses of two bodies, their distance from each other, and the gravitational force they would feel. An exception to this rule would be one of several possibilities: that there is no correlation beyond our solar system, that there is a different correlation, or that additional variables must be added to the stew. Still, it makes sense to call the exception a hypothesis. And we can let the philosophers debate whether mass is a cause of gravity, even though it is common speak in the Einstein world of gravity to say that mass causes space-time to warp. This issue, how to turn a correlation into a causal relationship, will be addressed in the later videos on causality. Despite this complexity, each of the three metaphysical approaches reviewed in the previous video tend to put their eggs in different inference Easter egg baskets. Quickly, each approach, unrealism, hybrid realism, and realism, tends to utilize a different combination of the inference methods. Unrealism emphasizes mathematical deduction and induced constants. There is no attempt to abductively explain why a particular thing happens, or to marry an underlying reality with our experience. In a compromise, hybrid realism attempts to deduce our experience from existing abstractions as an abductive explanation for experience. There is no need to inductively determine such things as constants, since they would logically follow from the abstract underlying reality. As for realism, it takes reality at face value. Some existing object is doing something that abductively explains what we see. We just can't see the object, so we have to use induction to determine its properties. Deduction takes a back seat since our prior reasoning cannot see beyond its own first principles, which science needs to do in order to make progress. Not to sound like a broken record, this scheme is a gross oversimplification. Each metaphysical position can and does use what it considers the bad egg, at least the formal process of the bad egg. However, each approach tends to use metaphysics as a justification for its own starting point, and unfortunately for blunting, or at least not actively pursuing, certain lines of questioning. So what does this breakdown get us besides the craving for chocolate? At this point, it is more of a suggestion than an argument. It is almost a matter of faith. It is like a huge pimple in the middle of our face that we wish with all our hearts would go away on its own. It has to do with how we answer the questions: what happened, what is happening, or what will happen. It is how we characterize what an event is, and by extension, what the fundamental nature of the universe is. Specifically, it is how we answer two big face pimple questions: are events determined, and are events causal? At first blush, it may seem an unquestionable truth that our universe is both resoundingly determined and causal. In other words, an event is determined because something caused it, and that a cause-effect relationship implies a determined relationship. Unfortunately, quantum mechanics has ripped them asunder, so we need to look deeper into the issue. But not too deep. We don't want to get lost in the tall grass. And I don't need to in order to make my point, that being each metaphysical approach answers these two questions differently, and consequently favors different inference engines. For simplicity, which has been the rallying cry for my simple mind, let's just use the following definitions. Events are determined if they are law-governed. Events are causal if they are spatially and temporally conjoined. Good thing I'm a simple beggar, because these definitions beg so many questions. But we will have to set them aside to see where the definitions take us. Continuing on, an example of a decidedly determined event is the orbit of Mercury, following the path set out by Einstein's general relativity. An example of a causal event is the classic billiard ball collision, one ball hitting others. With these simplest of definitions, quantum mechanics cleaves determinism from causality. And no, we can't go in search of quantum demons like Descartes' evil genius for playing tricks with our minds to resolve this issue. So I have to ask, what is it about QM that has shaken us to the depths of our heart and soul, that has generated all this angst? It all has to do with the double-slit experiment. Ever since G.I. Taylor's 1909 experiment with photons and Klaus Johnson's 1961 experiment with electrons, QM has been the stubborn gingerbread man, ceaselessly taunting us, "You can't catch me." It makes us doubt the unity of an object and throws phantom objects at us, almost like an ethereal spirit standing right in front of us, asking if she exists. It makes us ask ourselves, is there a single reality that determines and causes what we see? I intentionally leave the term reality ambiguous at this point because this is part of the problem facing us. Still, how we subconsciously or overtly answer this reality question, as it stands, decides whether we believe events are determined and are causal, and consequently the inference engines open to us. Returning to our Easter egg basket scenario, here is a non-chocolate table summarizing our results. Again, there are the three metaphysical approaches, unrealism, hybrid realism, and yocto realism, along with the preferred inference engines, deduction, induction, and abduction. In addition, I have added two columns for determined events or causal events, and I have added a column to characterize how each metaphysical approach views reality. The purpose of the table is to show how a metaphysical approach and its favored inference engines correlates with the properties of an event and the reality view. From there, we can see the tweaked sophysism underlying each metaphysical approach. I know this seems like a bit much to take in right now, but the goal is to offer an explanation for why physicists, sophicists, and metaphysicians are pursuing the solutions we are pursuing, for why we do what we do. It is kind of a realist approach, employing induction and abductions to the psychology of fundamental physics. Granted, most would probably say that the exploration is a big waste of time and has no place in science, but that ignores science as a human endeavor. Science is not as objective as some would maintain, or as some would want the public to believe. Factors like personality, popularism, politics, and prejudice, the 4 Ps, all have a hand in tweaking and turning the truth machine. Rather than dive into the grease and dirt of that part of the machine, I am just trying to get at the sophistic basics, and I hope that I am presenting it without prejudice. Well, at least with minimal prejudice, to keep things entertaining. I am human after all, at least the last time I checked. Let's start over with a clean slate. Let's return to our partially filled out table and start with unrealism. Briefly, unrealism denies reality by saying it is an illusion or it is irrelevant. It puts a big goose egg in the reality score column. The justification for this position is that QM precludes an existing reality, and therefore a Lego model, in principle, cannot explain the outcomes of QM experiments. Without an underlying reality to allow us to work our sophistic magic on, we can't instill any objects or events with causal efficacy. Causal events also fall in the loss column. Consequently, the best we can hope for are laws that generate prediction, of which we have a cornucopia full of fruitful symmetry. Such laws are truths since they match an outcome. Chalk up a win for determined events that laws govern. The result of all this is that QM is primarily an inductive sport, and that relativity is primarily a deductive mental game. Particle physics sits on the fence and employs both deduction and induction. Deduction to advance potential particles, and induction to establish constants. Unfortunately, abduction has not been invited to the science party. Physicists may use some of the party favors from abduction, such as hypothesis and experiment, but the result is not an explanation, a breakdown of what is really happening. Scratch abduction. Let's clean up the table a bit before the next course, the entree, which seems to be gaining in popularity. In summary, unrealism plays to its strengths and past successes, and puts a hard cap on human understanding and certain avenues of inquiry. Time to serve up hybrid realism. In a nutshell, hybrid realism, unlike unrealism, keeps a single true reality despite the phantom multiplicity of QM. However, it comes with a cost. It is a reality put in juxtaposition to human reality or to everyday experience. Unlike human experience, this brave new reality is an abstraction. It is an alien baby reality. There are a number of interesting approaches, but they generally take one of two directions. One, start from a fundamentally simpler reality, or two, start from a fundamentally more complex reality. As I alluded to in the last video, the simpler reality thesis tends to focus on object reality and tweaking its principles, for example, calling objects emergent and events/causality fundamental. On the other hand, the contention for a more complex reality put its faith in the infinite unreal and adds more dimensionality to it, using, for example, higher dimensional numbers or geometric objects. The justification for both of these approaches is that quantum reality is so unlike deceptive human experience that another qualitatively different reality must lie at the foundation of our universe, a reality where a P can exist under more than one shell at a time or disappear altogether. At its sophysistic core, human experience becomes a poor excuse for true reality. It is either too emergent or too approximate to portray accurately what is precisely happening in the Yocto realm. And what is happening in the Yocto realm? To return filling out our table entries. Abstract elements are interacting like qubits in a quantum computer to generate events, but it is not an event that we can perceive or even imagine in theory, only intellectualize from outside the box. Consequently, causal events take on the form, but not any of the content of causality. It is a new sophysism without the plus. Likewise, determined events are reduced and simplified. A single specific quantum outcome cannot be predicted, since this new reality is inherently an unknowable die set. We have a problem, though, since we only have one fundamental reality to play with. It can't be both an absolute deterministic and probabilistic world at the same time, like what might be possible in a Parmenides one world, in which all properties exist at the same time. Ergo, the best we can hope for is probability laws governing a population of outcomes, where anybody can win. Predetermination must be poured down the drain in order to keep a form of determinism. Outcome conforms to deterministic law, but what the outcome will be, nobody can say with any certainty. My apologies to Professor Einstein, winner of a Nobel Prize in 1921, a Copley Medal in 1926, and a Franklin Medal in 1935, to name a few, for defacing his photo. As for the inference engine, it is a little more complex and yet simpler than the current table suggests. Deduction and abduction kind of merge into one, just like we are trying to merge relativity and quantum mechanics under one law. Abstract becomes real and vice versa, if that makes sense. Also, particle physics becomes a solely deductive enterprise, since hybrid real solutions can feed constants and correlations into particle physics. Induction has become the uncouth cousin who prefers garlic fries, tuna pizza, donuts, and bargain beer for dinner. The horror. In terms of the inference engines and reality, hybrid real solutions seem to make progress with a compromised rearrangement of key ingredients in fundamental physics and metaphysics. Also, they provide a map for how physics can proceed, so long as we can come up with a sufficiently robust abstract model to ground further inquiry. My head is overstuffed with brain food, so it is time to clean off the table. To pause a bit and appreciate our meal with a good brandy, hybrid realism allows us to stay in our culinary comfort zone with a single and unified reality. but it still challenges our mental taste buds with its intellectualized and probabilistic notes. I'm ready for a real-to-goodness dessert. It is time to succumb to the sweet succulence of realism. Given that the none and one reality options have already been taken, the only options left are schemes that employ more than one reality, whether that be 2, 24, or a hell of a lot more. I'm not going to spend as much time as I did for the prior two metaphysical approaches. I will just unveil the entries with a brief explanation. Generally, this multitude of realities is the only twist to Yakta reality. It proceeds according to object reality or near object reality, with causality either happening or not between the realities. Correspondingly, the rules are more descriptive than governing, which leaves open the possibility that some events can be indeterministic and not universal. As for the engines, it is the most like other disciplines such as genetics and biology. When it comes to theory derived from abduction and correlation resulting from induction. Consequently, relativity, QM, and particle physics all fit in a single box under abduction and induction. As for deduction, the first principles of object reality provide the framework, but not the content of reality. Deduction can and should be used to extend and confirm the model from other principles. However, it is not at the foundation of any models. The big hullabaloo for the Yakta realist position is having to account for multiple realities, especially given that there can only be one infinite unreal in a traditional sophysistic model. If we can get past that one anomaly, everything else works according to familiar object reality, more or less. And that is that. Wasn't that fun? Sorry for this digression, but it had to be done. It is kind of like going to a cognitive behavioral therapist, or CBT for short, to shine a light on how one's habit of thinking betrays oneself. Yeah, sure, going over one's traumatic personal history and talking through it in psychotherapy helps, but until one sees the mental gymnastics that one is performing in real time, it is difficult to get out of a cyclic rut. Graduating to cognitive behavioral therapy can uncover new pathways of thought. Thanks to my daughter, who just graduated with a degree in psychology, for providing the analogy. It was a COVID online graduation, which was kind of anticlimactic, but she got to participate in my son's COVID car graduation, which was a little more exciting, except for the waiting in line part. Now back to the story at hand, which isn't nearly as mind-numbing, but probably just as ho-hum. The next story, personal in nature, will be about how we propose events to explain the current state of an object. One of my chores as a kid was to take out the clean dishes and utensils from the dishwasher. I grew to particularly dislike this chore, but I was dutiful in performing it, even if I was a little rough in putting stuff away. We own 2 cheese slicers, which we primarily use to cut Velveeta cheese blocks in the crafting of grilled cheese sandwiches. It is always important to read the fine print, especially the last item in the list. The warnings always come after the spells. Velveeta grilled cheese sandwiches, along with Campbell's tomato soup, was a once every 2 weeks comfort food that my mom prepared for us. We thought it was a great treat, but now that I think about it, it was more of a treat for my mom, since she worked as an elementary school teacher and often came home tired. Kids will do that to you. As part of the treat, we got to sit in front of the TV and watch one of our favorite shows. I can't remember which one exactly, but Bonanza comes to mind, even though that can't be it. Bonanza aired Sunday night. Here is a spot of trivia. Did you know that Leonard Nimoy of Spock fame actually had a part in one episode of Bonanza 6 years prior to playing Spock? I don't remember ever connecting the two, but there are pictures, so it must be true. Mixing realities is a foreign concept to kids, like seeing your beloved kindergarten teacher at the grocery store for the first time. I sometimes long for the simple perspective kids have of reality. Maybe I will eventually get my birthday wish. Anywho, the next day I put away the dishes, including the Velveeta cheese slicer. Then I ran upstairs to work on my homework. About 15 minutes later, my mom came upstairs and asked if I had broken the cheese slicer. I said no, didn't think much about it, and returned to my homework. Another quarter hour went by, and then my mom called me downstairs. When I got downstairs, I could tell that something was up. My mom and dad were sitting at the kitchen table with somber looks on their faces. My sister was sitting on the nearby couch doing her sisterly things with a smirk on her face. On the table was a broken-in-half metal Velveeta cheese slicer as big as day. I could tell that there was going to be a trial, and I was the defendant. I immediately adopted my alter ego in preparation for battle. Truth was big in my family, so over the next half an hour, I sat in my chair facing forward in defiance as my parents lectured me about the importance of not lying. Every now and then they would stop to ask if I still maintained that I had not broken the cheese slicer. Believing in a just universe where truth always prevailed, I never wavered in my answer. I had not broken the cheese slicer, and no, I did not know how it became broken or who broke it. I was tempted to point an accusing digit at my sister to wipe that smirk off her face, but I resisted going down the dark path. Near tears, I was sent back to my room, where I was to be incarcerated until I provided them with a confession. Over what seemed like ages, my parents took turns alternating between good cop and bad cop. In between interrogations, I alternated between crying into my pillow and crafting arguments to prove my innocence. To shorten a long story, I eventually gave up and falsely confessed to the crime, just to end my misery. Case closed. Guilty as charged. Punishment, 1 month. No allowance. End of story, or so I thought. A week later, my mother decided to put away the dishes instead of waiting for me to ride my bike home from Little League practice. As coincidence would have it, the other cheese slicer was in the dishwasher, and my mother threw it into the silverware drawer. Something about the configuration of the cheese slicer, the repeated dishwashing, and the drawer combined to crack the aluminum metal alloy when it was tossed into the drawer. In scientific fashion, we had duplicated this experiment in physics as well as ethics. It was karma. I tried not to be too smug. Karma doesn't like that. Of course, my parents felt horrible, and they apologized profusely. I forgave them, eventually. Later in my young adult years, I blamed them for all my maturing pains because of this one incident. Unfortunately, they didn't buy it. My karma has a short shelf life. So let's see what we can learn by revisiting, from my mother's perspective, what happened in the first case of the broken cheese slicer mystery. Empathy is important to ethics, or science for that matter. It is what makes objectivity possible, the ability to see things through another's eyes. In the case of science, the eyes we adopt are those of reality, which are universal eyes, the eyes we all happen to share. A quick interesting aside. This trait might not be limited to humans. Some scientists, such as Professor Laurie Santos of Yale University, are trying to discover if monkeys have this ability too. This ability to simulate what another consciousness perceives and feels. Alert! The researchers are also trying to save the rhesus monkeys on Cayo Santiago after Hurricane Maria hit in 2017. Here are the basic elements my mother probably used to get at her truth, to get at what really happened. Question, rules, facts, and conclusion. Before jumping into these 4 elements of this problem-solving example in detail, I want to give a little bit of a roadmap. This video and the last one about events will be taking some twists and turns. Along those lines, we will be taking a few side trips to give some historical perspective and how these elements play out when the process is spread out over a multitude of generations. We don't want to get too sidetracked in the middle of our quest to conquer the Matterhorn. The current video, the third in this 4-part series about events, will focus on the first 2 elements, the question and the rules. In the portion dealing with the question element, we will note how a question or questions can drive discovery. In particular, we will start with how the question of life popped up across many cultures and lasted for many centuries. More importantly, we will propose that there is a critical time in history, a crux. The crux happens when one or more events force us to doubt our own reality, or at least our working assumptions about it. It is the unanswered question that creates the crisis in science. Science, after all, is supposed to be the fountain of truth, of rationality, and if it can't answer its own question, well then something must be rotten in Copenhagen, to twist a phrase. Despite this fear, the failure to find truth over many generations does not imply a failure of science. Rather, these cruxes are as important to science as a resolution is. And several storylines usually conspire to make a resolution harder and yet easier at the same time to achieve. For example, the crux for genetics, to way oversimplify things, was the confluence of morphological taxonomy, Darwin's theory of evolution, and Mendel's laws of inheritance. These disciplines conspire to resolve with the discovery of DNA and its remarkable properties. It may seem weird to call such successful discoveries the source of a crisis, but the crux hinges on their individual viewpoints and validities pitted against their combined incongruities. Such conflict is common in most human endeavors, especially in fictional stories. We will compare how a historical crux can be like the crux in a theatrical play, which is the post-midway point in the play when the storylines crash into each other. It is the time in the play when all hell breaks loose, which may be a good or bad thing depending on where you are sitting. However, unlike a play which has a finale, the storylines in histories continue ad infinitum. For example, abiogenesis, the origin of life, has yet to be resolved. Questions always begat more questions. Life is like a binge-watching session of Veep that we cannot escape or fast-forward through. Likewise, physics has its own crux. We are currently at a crossroads with Einstein's theory of relativity, quantum mechanics, and the standard model of particle physics. We will see that the parallel between genetics and physics is in many ways uncanny. Unlike genetics, however, physics has yet to reach its resolution. There is no DNA for existence. In other words, there is no existing thing like DNA that we can point to as a fundament of our world to explain all that we see. And that is the reason the question will drive us, is driving us, until we get a satisfactory answer, even though some would maintain that a DNA-like resolution is an impossible path for physics to cross. However, it is against our nature to leave a tire unturned, no matter how big the tire. The end game of the 4 videos about events is to show how focusing on laws and not the inertial portion of the principle of relativity blocks us from looking at the more pertinent questions. We are searching under the wrong rock. For the section on rules, we will look at how rules provide potential answers to our questions. We will also see how physics has perverted that rule by using additional metaphysics to isolate rules. In order to illustrate how that's done, we will preview a hypothetical about some multiverse explorers. This will be the cliffhanger at the end of this video. In the next video, we will suggest how Aristotle and Galileo might have answered the hypothetical. From the hypothetical, we'll see that physics currently has an exaggerated bias toward confining its rules within the infinite unreal and refusing to let them out. As a temporary solution, that works, but as an end unto itself, it is a dead end. Instead, we need to adopt an approach that emphasizes object reality more in order to get beyond the crux and reach a resolution in physics. I will spell out the rest of the roadmap for the next 2 elements, facts and conclusions, when we get to the 4th video. It is still a work in progress. By the way, these are not hard and fast arguments, but more inklings to where we are headed. Just some things to consider, a warm-up, if you will. Okay, back to the topic at hand. In listing out these 4 elements, question, rules, facts, and conclusion, I do not mean to imply that we are simple computer programmers, following one step after the other when we problem solve. The process is much more free-form than that. More often than not, we jump around from one to the other, often visiting each step several times or working several steps in parallel. Most of us are jazzists when it comes to everyday problem solving. Another way to look at it is to compare it to one big Sudoku puzzle. We are given a partial picture, and we have to fill in the rest. Sometimes it is easy, and sometimes it is hard. Sometimes we guess wrong, and sometimes we are able to solve the puzzle. Of course, Sudoku is just a game. As such, its rules are simple and invariant. I cannot imagine how difficult Sudoku would be if new numbers were introduced in the middle of a game, if numbers moved on their own accord, or if chess pieces started to attack the board. As it is, I am lucky if I can make it through a tenderfoot Sudoku. It is interesting to note that most man-made puzzles have a single solution. However, there is nothing in the rule books that says a man-made puzzle, or even a natural one, must be limited to a single solution. For example, given insufficient initial numbers in a Sudoku puzzle, it is possible to have more than one solution. In addition, given too many numbers, a Sudoku puzzle might not have any solution. That is based on my going down the wrong path and being unable to complete a puzzle. I have sworn off Sudoku puzzles. Still, whether there is a single solution for physics is one of the metaphysical assumptions currently up for grabs, like a curve alert free-for-all. At the extremes, according to some, there may be gobs more solutions available, like in string theory or antecedent M theory, or there might not be any object real solution. In effect, we have reached the end of the sidewalk, beyond which the human mind can neither comprehend nor visualize. That is a shout-out to Shel Silverstein's Where the Sidewalk Ends, Poems and Drawings. The book was a favorite of my kids growing up. It is not a reference to the 1950s movie of the same name. To be clear, I'm in the camp that believes one and only one solution is possible when it comes to the fundaments underlying our world. Time will tell, But the more I dig into the issue, the more I am convinced that a single full-blown object-real solution is possible and will eventually arise. So convinced, in fact, that in the next video I will outline my object model, at least the main sophistical portions of it. The only thing going forward at this point is its simplistic chutzpah, something that I believe is required to zero in on the crucial issues. It can potentially explain, among other things, how we can apply the atomic principle to fundamental particles, how we all can see the same thing, and finally how inertia can be explained abductively. At this point, it is not like special relativity, which was deduced from simple first principles. Nor is it like quantum mechanics, which inductively match mathematical functions to observe phenomena. It is a wild-ass abductive guess that fits the constraints that relativity, quantum mechanics, and the standard model put on us. And it would require us to look at reality differently in terms of our current set of sophistic assumptions. I'm probably looking at it through rose-colored glasses, though. If only you could see what I have seen with your eyes, to quote a line from Blade Runner. To be honest, at this stage, the physical model hasn't been put through any experimental ringers, real or thought, yet, and it is no better than the musings of a doddering metaphysician. That is why the scientific method is crucial for science to confirm guesses and get consensus, and why nailing the right question, in other words setting up the puzzle, is equally important. It forces us to be cognizant of the assumptions upon which the question is based. For me, it is the assumption that a physical world model which conforms with and confirms all three principles of object reality and their corollaries is possible. If we accept that assumption, the question, what is happening, naturally follows along with the question, what molten goop is at the foundation of our world. Regrettably, unlike a daily Sudoku puzzle in which we know there is a single solution, a single answer at the end of the tunnel, chasing an open question in physics holds no such promise. It is more akin to navigating a three-dimensional maze with lots of dead ends and no certainty of an exit. So, using our current cheese slicer example, let's walk through the first two elements, question and rules, to see what they entail, to see what guardrails they set up. Let's start with the question part. My mom was surprised to discover the broken cheese slicer. Most objects and events that we encounter in our normal day-to-day do not trigger the big question, what happened? Or more appropriately, what in the bleep just happened? In contrast, our life experiences make most things old hat. For example, it is easy to explain how my prescription sunglasses with the removable lenses as thick as Coke bottle bottoms came to sit on the desk where I placed them after walking the dog, or why the people are crossing the street at the intersection with a walk signal as I wait at the light. Most things are, well, pedestrian. However, life prepares little surprises for us. It is the surprises that cause us to wonder, for example, at the attraction two wires feel with a current passing through them, which results from special relativity, or the weird pure colors reflecting off of a DVD at weird angles, which is quantum mechanical. From there to here and here to there, funny things are everywhere. One just needs to know where to look. Not that all surprises are rare or hard to find. Take life, for example. We see the fruit of this long-hidden, but now fairly well-understood process every time a new plant sprouts from a seed or a human baby matures. I would even go as far to say that the more important surprises are the ones that are obvious everyday miracles. Sometimes the surprises are right under our nose. We just need to open our eyes. Perhaps even existence itself, or at least our experience of it, is one of these everyday miracles. Interestingly enough, early attempts at an explanation of life appeared in most cultures, if not all, some better than others. For example, in ancient India, the Charaka and Samhita, written during the pre-2nd century CE period, is one such example. It described 4 elements that led to a particular child: the mother's reproductive material, the father's, the diet of the pregnant mother, and the quality of the soul entering the child's body. Eerily similar to modern-day genetics. See, karma is important. In Western civilization, there were several antique hypotheses about life that also incorporate religious mysticism. For example, there was a preformation theory, which proposed that little preformed homunculi present in the spermatozoa of all species were implanted in the female. That was attractive to many natural philosophers because it saved them from having to figure out how something animate could be created from something inanimate, which in some schemes Prometheus was originally rumored to have done for man. Later in his place, God with a big G, was given responsibility for creating the first organisms, the first templates. In competition with the pre-formation theory, there was the epigenesis theory, which took into account how an embryo develops from a potential indiscriminate clump into an actual complex organism. Again, in many of the versions, it was a male-centric theory. The male supplied the potentiality, the blueprint to sculpt the female menstrual blood, the material cause or matter, into an organism. I believe that is where the expression of the same blood and bloodline come from, but I haven't been able to confirm that. The epigenesis hypothesis avoided some of the metaphysical issues with pre-formation theory, such as how an infinite number of homunculi could be present in the original man. By the way, putting the infinite into object reality, as a pre-formation theory does, always creates impossible problems and paradoxes. Despite its improvement over pre-formation, epigenesis still required something or someone to sprinkle a bit of soul dust at the critical moment to cook an inanimate object into a living and breathing human. There was even a point in the story at which the all-pervading life force, or pneuma, captured in breath, spilled over into physics and sparked the idea of an all-pervading ether. Just to be clear, nothing like a life force, an all-pervading spirit, or even a fundamental consciousness will be a part of my physical model in the next video. These two theories, pre-formation and epigenesis, in one form or another, have been at each other's throats for the better part of 2 millennium, circling each other, one getting the upper hand for a while, then the other dominating as they both evolved. Remnants from these two theories can be found in the nature versus nurture debate, as it relates to behavior, and even more recently in some physical traits. At its foundation is a metaphysical debate between determinism and indeterminism. To put it into genetics terms, it was a debate between genetic determinism and developmental free will. Historically, as one side gains momentum, it tries to consume more and more of the opposing side, not always successfully, in an attempt to win the competition. A case in point is Darwin's proposal of a modified epigenesis, which he called pangenesis, to drive evolution. He hypothesized that the traits both parents acquired after birth were stored in coded form within the gonads. For example, different parental exposure to the sun would result in children tinted somewhere in between. According to pangenesis, life experience created pangenes, or gemmules, which the parents would then pass on to their kids as a blended analog. There was nothing in the theory of evolution that required pangenes, that evolutionary first principles necessitated. It was just Darwin's best abductive guess. It seemed like a logical way to facilitate evolution without having to resort to pneumata, even though Darwin did not test his proposal with nitty-gritty experimentation. Just observation, the hallmark of induction and not abduction, which relies primarily on putting guesses to the test. Darwin was more focused on populations, diversity, and survival, rather than the actual mechanism of heredity. If anything, the theory of evolution is contrary to the well-established rule that like begets like. Evolution requires diversity, in other words, like begets slightly unlike. This problem of heredity gave Darwin extreme heartburn. He struggled with this question for years, finally presenting his pangenesis theory in book form in 1868, but was never really satisfied with the result, nor were his critics. Just like the difficulty of finding unity in physics, in which everything is quantumly superimposed, the theory of evolution takes us a step away from the basic question driving this quest, how like becomes like. It is like trying to contain a fusion reaction, which wants to keep blowing things up. The analog blending of the proposed pangenes was an improvement over the male-centric epigenesis cloning, but as Fleming-Jenkins' statistical arguments and Mendel's P experiments showed, Darwin did not get the heredity piece right. Jenkins' statistical arguments proved mathematically that rather than tending toward diversity, Darwin's pangenesis would tend toward uniformity. It would be like the gray goo that would consume everything if self-replicating nanotechnology ran amok. It was a scathing deductive counter-argument. Something other than pangenesis, which just didn't add up, was required. That something other was pointed to by Gregor Mendel's laws of heredity. Mendel only knew one statue posed, by the way. Mendel's theory was more digital than analog. He proposed a pairing of dominant and recessive entities that controlled such traits as seed texture and flower color in pea plants. This model followed simple probabilistic ratios that his extensive experimentation elucidated and confirmed. Despite this discovery, Mendel's meticulous artwork was ignored, largely because he was an amateur scientist and because the world was still trying to get its head around Darwin's theory of evolution. Only one earth-shattering idea is allowed per generation. A generation after Mendel's death, when the world was ready, the almost simultaneous and independent rediscovery of Mendel's laws by 4 scientists was the trigger that drove us toward molecular genetics. As is often the case in science, when a new phenomenon is discovered, a name is given to it to give it objective substance, like naming a new highway. It was Danish botanist Wilhelm Johansen who coined the term gene in 1909. It was the tipping point, the beginning of the resolution in the genetics story. If we need an antagonist at this point in the story, we don't have to look far. Eugenics raised its ugly head, and it was not confined to Hitler's Germany. There were many proponents across the globe, including in my United States, to our great shame. It took almost 40 years to rule that forced sterilization was unconstitutional, and another 20 years before the practice was completely abandoned against people of color and the poor. I suppose the parallel in physics would be the development of the atomic bomb, a necessary evil some would maintain, the sole purpose of which is the wiping out of thousands, if not millions, of people. If nations could receive a Darwin Award, that would be a top candidate. I don't know why cruces have to be tragic or threaten calamity in order to create tension. Maybe it has to do with our innate curiosity to crowd around an accident. We are a curiously primitive species for supposedly being so evolved. Maybe our evolution hasn't caught up with the demands of our man-made environment. If we accept the rough parallel between physics and genetics, this stage of genetics in the early 20th century will be where we are currently at in physics. And if physics is able to unify the 4 fundamental forces of nature, it would parallel what biology called the modern or grand synthesis. The grand synthesis was a theoretical fusion of genetics, taxonomy, and evolution. The story's protagonist was the Ukrainian biologist Theodosius Dobzhansky, who immigrated to the United States. Dobzhansky finished out his tenure as an emeritus professor at UC Davis, my alma mater, but I doubt our paths ever crossed, even though our time shortly did. Unfortunately, we, well, at least me, are usually oblivious when history comes close to touching us. Probably because Dobzhansky did not receive the same billing as Darwin and Mendel in my pre-collegiate science classes. In his experiment using fruit flies, Dobzhansky showed that an experimental environment could create an entirely new subspecies of fruit fly, unwilling or unable to mate with the original species. To put it in a unified single law-like statement, genes plus environment plus triggers plus chance yields the physical trait or phenotype. As a quick observation, if we wanted to make another correspondence between genetics and physics, we could line up some of the features of the Copenhagen interpretation with that of genetics. For example, both genes in the Schrödinger equation can be viewed as the foundation, the encoded starting point for explaining what we see. The parallel is more of an analogy, since genes were seen as a physical entity, and there is no corresponding physical entity for the Schrödinger equation, at least in most interpretations. However, it goes to the point that we have an idea of what the solution should sound and feel like, either explicitly or implicitly, and we work towards that. I got the genetic side of the equation, and much of the genetics history from Siddharth Mukherjee's The Gene and Intimate History, which is an enlightening read. Still, biologists were not satisfied with genetics' grand unified theory. There had to be something special, some nuts and bolts mechanism that could explain how life works. There just had to be. In 1928, the shy and reluctant biologist Frederick Griffith published his findings about how a lethal property within dead and pulverized bacteria could be transferred to non-lethal and living bacteria. The result was mutant killer bugs. There is definitely no ethereal pneumata at work here. Something like a physical chemical such as protein was involved. No miracle ethereal life force was needed to distinguish between the inanimate and the animate. It was like Einstein's dismissal of a single all-pervading ether as the instantiation of the infinite unreal. There are other important steps in this story, but we're going to fast forward through history in the interest of time, even though it is an interesting read. We are going to pick up at the historical resolution for genetics. The big break in solving life's mystery occurred in 1953, when James D. Watson and Francis H.C. Crick were able to model the DNA double helix using wooden balls and sticks based on experimental evidence, such as X-ray diffraction. I would be remiss if I did not mention Rosalind Franklin, who provided the all-important X-ray diffraction photograph 51 that Watson and Crick used to construct their final model. Her pivotal role was initially downplayed and the picture was borrowed, in quotes, without her permission. Perhaps it had to do with her prickly personality or her womanhood, or a combination of the both amidst traditional distaste for strong women. Despite the behind-the-scenes shenanigans, DNA structure was the holy grail when it came to answering the questions that had eluded us for over 3,000 years. It explained how parents can pass on traits to their offspring, how variance drives evolution, and how organisms gestate and perform daily block-building maintenance. Out of almost limitless possibilities, only this single molecule would do the trick. Only this one molecule and its properties could explain so much, could explain life and all of its complex facets. Only one molecule could explain how like begets like and still create enough diversity for evolution to work. It is like a miniature Babbage difference engine, which had some quirks in it to introduce minute errors. By the way, I was fortunate enough to view a working Babbage difference engine at the Computer History Museum in Mountain View, California. The mock-up was faithfully reproduced from Charles Babbage's own blueprints, from which he never bothered to build his own machine. It is a beautiful thing to behold in action. It is almost like a living and breathing thing. There might be other molecules that can perform a similar trick as DNA, but we probably won't know that until we happen upon extraterrestrial life within our own solar system or beyond. So the big elephant in the room now becomes, is there a DNA-like solution for physics? Can we construct a octa-real model based on objects, events, and causality that explains all the classic relativity and weird non-classic quantum phenomena? The parallels between molecular genetics and fundamental physics gives hope that we can. However, some would maintain that at their roots the two disciplines are apples and oranges, and therefore their storylines must diverge. For instance, genetics describes a fluid system. That is how organisms can adapt to challenging environments. Life cannot sit still if it wants to survive and reproduce. In contrast, the fundamentals of our world seem to be set in stone. We don't have to look far beyond physical constants, such as the speed of light and the charge of an electron, to see that our universe is static at its heart. Symmetry, especially constancy over time, is the order of the day. This difference is what makes life so distinct from non-life or inorganics, which my son could talk about at length, and yet both are a part of the same world, a physical world. Further discussion of this difference will have to wait until the videos on causality. But what it comes down to is the difference between fate and chance, between deterministic causality and non-deterministic causality. Some may wish to call non-deterministic causality an oxymoron. However, advancing one form of causality as a true one and casting off the other as illusion would be a great disservice. Instead, if we take genetics as a model, these two forms of causality must be meshed to form a part of a larger working whole, a physical model, in which each plays an important part. That is why I believe physics' story is still a work in progress. The gap between non-deterministic and deterministic causality is closing, but still present and currently insurmountable. One more note to mention about genetics before going on to the discussion about how fictional stories mimic life and vice versa. Even though the discovery of DNA seems more like a find the missing object case, which we explored in the very first video, in truth it is a mixed bag. That is typical when trying to explain an unexplained phenomenon. For example, geneticists knew more than a decade before Watson and Crick published their findings that DNA was responsible for the mechanisms of heredity. The Avery-McLeod-McCarty experiment published in 1944 showed that DNA, and not protein, was the carrier of genetic information. Discovering the object was just one important step in the whole story, which still has yet to fully play out. Discovering DNA's structure and how it could perform those feats was the far more important piece of the pie. That is one of the reasons I put the story of genetics here rather than in the first video about objects. Coincidentally, the path that genetics took and that physics is currently undertaking is very similar to how some fictional stories are told. In some cases, it is by establishing a triad between elements. Art imitates life, and life imitates art. That is not to say that all storylines or scientific inquiries must have a triad intersection underlying them, just that it is one possible and very common construct. Time for another quick personal aside, which highlights another important principle about how the answer to a question rises to the top. I took a playwriting class once at a local community college. Well, actually, several times. It took a while for the lessons to sink in. One of the things that we learned was the structure of plays, how in a two-act play, the crux of a play is toward the end of Act 1. The crux is the point in the play when all of the story arcs introduced throughout the first act are focused into a singularity, and all actions from then on out flow from that single incident. It is when the first shoe drops and we spend the rest of the play waiting for the next. For example, in Wicked, which tells an alternate version of the Wizard of Oz story, the crux happens when Elphaba, the Wicked Witch of the West in the original, learns that the wizard is a fraud and that he is only interested in her witchy abilities to maintain power for himself. She is confronted with a moral question of what to do. In response, she decides to take control of her own destiny and defy gravity. That is the focal point of the play, the crux upon which the play turns. In the story Wicked, there is this triad of relationships that defines and drives the main story. The triad is the three relationships between Elphaba, Glinda the Good Witch of the South, and the wizard. What makes it interesting is the internal conflict that each character faces when confronted with the external conflict. As a case in point, Elphaba had to answer the question of how she was going to square her disavowal of the wizard with her love for her new best friend Glinda, who works within the wizard's sphere. Of course, to keep things interesting, there are additional characters, relationships, and subplots, but the three main relationships are the key to the power and impact of the story. All corny on paper, I know, but you had to be there. By the way, it was my daughter's idea to go, 2 times. At least that is the story I'm sticking to. And don't go looking at my song list. The question is what hangs over the players until a resolution is found. It is what keeps us on the edge of our seats. It is the tension that keeps us from falling asleep. Part of the resolution in Wicked was the mutual forgiveness and love Elphaba and Glinda the Good show each other, even though they reluctantly agree to part. In addition, Glinda disavows and banishes the wizard, who is revealed to be Elphaba's father, and who caused Elphaba's greenness. Likewise, in genetics, the discovery of DNA's structure, properties, and behavior was the, with a capital T, resolution in the history of genetics. However, it was not as dramatic as the resolution in Wicked. There wasn't even a song to go along with it. Still, the history of genetics is in many ways like a complex play with many subplots and storylines that span millennia. It was a regular scientific soap opera. In many human endeavors, there is this invisible hand that seems to create a pattern of events that plays out over and over. A hand that pushes us in one direction, toward an answer, toward a resolution. This despite our best attempts to alter or deny the pattern. In fact, denial may be an important part of the pattern. It is that old saw, can't see the forest for the trees. Of course, the hand I refer to is not supernatural or metaphysical. If I had to guess, I would say that similar tracks happen because of how objects, and that includes humans, interact given certain properties, constraints, and pushes. We like to think that we are somehow above the fray, but really combine a bunch of humans together and certain predictable patterns emerge. And at the forefront of investigating such patterns are questions like, what's happening? In the case of physics, even though squaring gravity with the other 3 fundamental forces will be an important step in the process, I would maintain that it is not the end game. It is a question that drives us and will perhaps allow us one day to find the DNA under our current reality. Quest is, after all, the etymological root of question. There are other questions that can drive us, such as what caused that, or worse, who's there? However, that is for later. It will be the next and final element of object reality that will be explored. By the way, objects, events, and causality also form a powerful triad, which will be explored on the videos on causality. I dislike introducing a topic and then letting it drop. However, given that these are introductory videos, more improvised than planned, I am forced into that lane. So the most I can do is give a taste of what is possible, given the foundation that is being laid for object reality. At best, from humble and boring beginnings come exciting potential, or at worst, a dead end from which we can learn what not to do. Time to get back down to earth, at least momentarily. As you may remember, we were going through my mother's problem-solving process to get at how the first cheese slicer broke before we were so rudely interrupted. After framing the question, she would most likely have gone through a series of guesses based on rules to come up with plausible explanations. Rules make the unexpected expected. Rules bring order to chaos. If the three principles of reality and their corollaries form the backbone of reality, rules fill out the rest of the body of experience. Halloween was happening as these words were originally written, so I had skeletons on the brain. Or as mentioned earlier, experiential rules add the plus to sophysism plus. For example, my mother might have thought to herself that things just don't break on their own if taken care of. Thermodynamics aside, also kids don't like to get into trouble, and they will hide bad deeds to avoid the wrath of a grumpy parent. And finally, dishwashers usually don't break utensils, especially metal ones, although it does do interesting things to plastic items that fall to the bottom. If we wanted to overthink things, we could probably come up with several more reasonable rules that could have been applied, such as my sister framing me. Imagination is important to finding applicable rules, to finding possible explanations. For example, if I was a fantasy writer and wanted to go fantastical, I could imagine fantastic beasts running about, unseen, breaking and displacing things, creating selective havoc. That is my best explanation for why I can never find my glasses. However, in the case at hand, we don't need to rely on such far-out explanations. Simply put, the repeated heating cycle of the dishwasher, which the instructions warned against, weakened the aluminum alloy sufficiently to make it susceptible to microfractures, then breakage when thrown into a hardwood silverware organizer. That is my best hypothesis/theory after all these years. It fits all the facts, which we will explore in the next video. Finally, I have clarity and resolution. I can finally forgive my parents. If we want to go full on techie, the pertinent rule I applied is an aluminum alloy with more than 3% magnesium becomes sensitive to stress corrosion, cracking after long-term exposure to temperatures above 150 degrees Fahrenheit. There are thousands of such rules, maybe not many so technical, that we generate or learn on the fly over the span of a lifetime, kind of like Calvin Ball. It might be fun to document all the typical ones that a modern world citizen needs to function in society. If I had to guess, it would be in the neighborhood of 20,000 or so, but that is just a bald-faced guess. If we analyze rules, they can have several functions, such as defining an object or event, laying out a generalization, or specifying a causal relationship. An example of a definition rule is water is liquid at room temperature. An example of a generalized rule is water is essential to life. And an example of a causal rule is water can erode solid objects. There are probably other types of rules that reality dances to, but that can wait. I'm only going to peel the first layer here and delay further discussion until the video is on causality. That is because rules form a major piece of causality, just like properties define objects and actions give life to events. Notice that I call these rules and not laws. Laws have a finality about them, an absoluteness about them. Laws are pronouncements which cannot and must never be broken or reversed. In science, they are set forth as always and forever true, even if they turn out not to be. At least that is the envisioned plan. Some believe that the primary, if not the sole function of fundamental physics, is to find the laws of nature underlying all of reality and yet outside of reality. That is a noble pursuit as long as it is agreed that laws in themselves are not object real or even big T true. It will be another thesis of these videos that laws like rules are conditional and approximate. And more importantly, they are conditional on both object reality and the infinite unreal, no matter how they are distilled, whether it be from experience or by deduction. All authority is subject to oversight and review. It is a fool's errand to find an absolute law that exists independent of experience, that exists solely in big N nature, like a weird ghost jellyfish floating nowhere in the infinite ocean. Would you look at the time, which I have run out of for this third video in what is now a 4-part series on events. I wanted to explore a hypothetical that illustrates how laws in fundamental physics are viewed, but I got carried away with a bit about how different metaphysical approaches emphasize different inference engines. Still, let's do a quick preview. In short, we can ask ourselves what would happen to a shipload of multiverse travelers who jump from our universe to a universe based on different constants such as gravity. Simply put, would they bring the constants of our quaint universe with them, or would they be subject to the rules of the new universe? Something to ponder on your next dog walk. I should take a refresher course on time management. Good thing I was not in charge of the Event Horizon Telescope, or EHT, which in 2019 realized the first image of a black hole, recently named Povehi, at the center of the nearby M87 galaxy. Povehi is a Hawaiian word meaning the crown, fathomless dark creation. They use the configuration of many coordinated radio telescopes spread across the world, ranging from Greenland to Antarctica, with more in between, to gain the required virtual magnification. The one in Hawaii atop Mauna Kea served as inspiration for the name Povehi. It was a decades-long collaboration between hundreds of astronomers and computer scientists. A picture is worth 5 petabytes, enough to fill half a ton of hard drives. By the way, that is Dr. Katie Bowman, who was a lead computer scientist on the EHT team. She was responsible for developing an algorithm to generate simple snapshots from such a truckload of data. The EHT team is currently working on imaging Sagittarius A+, which is the black hole at the center of our galaxy. It is shown here as a computer simulation. It is time to put the finishing touches on this piece of the garment. A lot of diverse, seemingly unrelated threads have been presented in this video, but the overall story arc comes down to 3 main swatches. 1. Quantum mechanics has rent determination from causality, creating a huge unanswered question about the nature of reality. 2. Each metaphysical alternative has tried to mend the rip by applying different or modified sophisistic rules. And number 3, as a history of genetics evidences a successful resolution will inevitably be reached in physics because of and despite these alternatives. In the next and final video about events, we shall finish what we left unfinished here. We shall look at the multiverse hypothetical. To suggest how the hypothetical could be answered, we shall compare potential solutions based on where it all began, between Aristotle and Galileo's imagined positions. We shall also finish out the everyday methodology of problem solving, namely facts and conclusions. Tucked away in the last video will be an overview of my yocto-realistic solution and how it resolves the riddles of fundamental particles and the unity of experience. Also tucked away in the last video will be the corollary to the second principle of object reality, namely how an event changes an object. Finally, if time permits, which I'm thinking it won't, we can make a guess at where an explanation of inertia is headed and how my yocto-realistic model answers it. Time to turn out the lights and hit the hay.